Very much. So, bonjour and good morning, everybody. As I was already presented, I'm glad to see that people come to these conferences not only to hear about how people are able to hack things, but also to understand how you can actually secure them so that you don't end up in a presentation like the ones going on in room number 2. And this is important because when I started, a couple months after I started working at Checkpoint about 13 years ago, so I was surfing the web and I reached some website, and suddenly I see a download happening, right? Maybe some of you have already had this happen. You just reach some website, something starts downloading and installing itself on my computer. First thing I do is unplug it, turn it off, restart the PC, and try to restore the previous version because I don't want to get this malware installed on my computer. And then the next day I walk into work and I come over to someone who's been there already for a while at Checkpoint, and I say, he works with web intelligence, and I say, listen, this and this happened to me. So the first thing he does is he looks at me and says, well, you shouldn't really be going to those kind of websites, But after I was able to convince him that it was actually a community website and that it's okay, but it's probably been hacked. So I said, okay, as a security expert, what do I do? And he looked at me and he said, what do you mean? You work at Checkpoint. It's a cybersecurity company. You're a security expert. And that was the point when I realized that really what we all have to be able to do is to switch from being just a developer that develops software, develops cyber software, and we actually have to become the architect. We have to become architects that understand in security, that understand what we're doing in cyber, in software development, and really get the security done right. Which is also what led me in what I do now is something called security leader in Checkpoint, which is in charge of basically the SDLC that we're going to be discussing today. And really what I've been trying to do for the past 4 years that I'm in this position is to shift the security to the left. And I'll talk about that a bit more later. Also, every presentation has to have a picture of puppies or kittens, so we got that through. Check. We can go on. So why is cyber software, the security development so much different than any other software? Okay, so every software has to be secure. When we come to cybersecurity software, it's like the difference between some mushroom, that if the mushroom gets crushed, so maybe an animal won't be able to eat it, maybe we won't be able to get it, it won't be pretty anymore. But if cybersecurity gets crushed or crashed, then we have much worse mushroom to deal with that we really have to handle. Here's a small table basically trying to show, I've brought like a few different vulnerabilities or bugs that can happen in our software. And the difference that would happen between just some regular software, if it's a calculator, Word, or anything like that, as opposed to something happening on our enterprise firewall, okay, where instead of just something crashing or losing some calculations, we can reach a point where either our network is DOS'd or the network is infiltrated. And if we have something on our PC antivirus, the same thing. If the viruses can start flowing through because our software wasn't secure enough, then we have a much bigger problem. So let's just do a small recap on the development lifecycle and how we make it secure. So the development lifecycle, whether it's Agile, Waterfall, or any other paradigm that you're using, basically goes through the same stages. Okay, maybe it does it differently, but it goes through the same stages. And the requirements, planning, design, development, releasing, maintenance afterwards. And we're going to go through each of these and understand how we make them more secure. To make them more secure, and to go back to what the shifting left actually means, shifting left, if you haven't heard about it yet, what it basically means is this is our development lifecycle that we just talked about. And we want to take the security and move it to the left. Security used to be all the way up here in the past, right? We just had the security there, so people developed. We went through QA, we went through verification, we did everything. And then the last moment, it came to the security team. And the security team checks in and says, this is crap. You have to get it, you have to fix things. And sometimes it's already too late because we already promised the customer that he's going to get it soon. We have to take care of that. So the idea is basically shifting to the left. This picture is taken from an IBM research that was done, And it also shows the price of fixing the defects at the different stages of the development. Okay, so it's not only, it won't only help us get things out faster, it'll also reduce the price and the cost because we're fixing things at the real beginning. So that is the idea of shifting to the left. The idea of shifting to the left is basically adding security to every step of the way while we are developing to make sure we get it right. So that means if we used to have a design review, so we want to have a security design review. Okay, we want to be able to look at the security aspects of our design and understand if we're doing them right. If we had code review, okay, a lot of us do code review in all the code that we develop, so we want to have a secure code review. Let's look at the actual points, the inputs, the outputs, make sure that we're doing it securely. If we always had testing, we always had QA, we had verification, we want to do pen testing as well. Okay, we want to make sure that that is also secure, and basically any other step along the way, we want to make sure that we have a security, etc. going through. So, where do we start? How do we start with securing everything? We start off with training. Okay, so we really have to get security training done right. And security training, I believe, starts with secure coding training. Okay, we're not going to do secure coding training, but it starts with secure coding. And secure coding isn't just, one set of rules. It really has to do with every language we're using and the pitfalls per language and which platforms we're using. What kind of software are we developing? Is it client? Is it server? Is it web? Is it client software? We have to understand what we're doing and get it right. So we have to understand how to code securely. We also have to have, you can see it. This is coding style. Okay, we have to have coding style guidelines. If we write our code in a way that we can read it, that anybody can look at the code and review it and read it and understand what's happening there, it makes it easier for us to understand where our bugs are. It makes it easier for us to understand how to, where things were implemented the right way or where we were trying to go around. And maybe then that's where things start going wrong. And it also helps us fix things much faster and much more efficiently if the code looks in a regular style guideline. One more thing is that if we have good code, then, as Guilfoyle says, we can have much, much better performance if we have our code going right. Okay, because it'll just happen the right way and not try to avoid everything. So, as I said, we're not going to do a secure coding training here, but the one thing that if I were to do a secure coding training that I would want you guys to take with you is input validation. Okay, and the importance of input validation. And I really believe that almost every security bug and vulnerability that we have in all the products around start with checking the inputs to the system, because that's how you infiltrate a system. You get the input. So if we have our input and we check our syntax, and we check our semantics, and only then we get it into the privileged code, once we did good input validation, then we're set and we can go. So for the sake of this presentation, I'm going to make believe that we're inventing a new software. We're going to call it the Malware Buster. Okay, and the Malware Buster, as it sounds, basically what it does is it has a lot of traffic going through. Okay, this isn't based on a real Checkpoint product. But it's like I'm taking a few products and ways that we've designed them into the Malware Buster. Basically, what it does is it gets a lot of traffic running through very, very fast. When it sees something strange, it knocks it out. Okay, it gets rid of it. It does this statically. It does this dynamically, and it does it and it checks it on various platforms and operating systems to make sure that the file that we're downloading isn't malicious and that we can take care of it. So that's our Malware Buster, okay? And basically when we look at it, this is what it's going to look like. We're going to have the internet, we're going to have our endpoint, we're going to have the Malware Buster in the middle, okay? Yeah, I was never really good at drawing. I leave that to my kids. So, first stage in developing the Malware Buster is we have to go through requirements, right? Because requirements is something that we have to have. If we don't have requirements, we don't have them right, we can't go on and we don't understand what we're actually developing. So, when we start with requirements, we start with a lot of questions. What are we actually trying to build? How secure are we trying to make it? Who's going to be using it? Where are we going to install it? What kind of operating system? There are a lot of questions. This is where the dilemmas start coming through, because we really have to decide what we want to develop and how we want it to look in order to get it through. So, for example, who's the user base for our software? Is it administrators? Then it can be something very sophisticated. Or is it any user, like in antivirus, it just became like a one-click on-off, right? So then we understand how we're going to develop our software. What kind of physical access will we have to our application? Will the physical access be will there be any physical access to it? Or is it something that's like installed in some lab and nobody is ever supposed to reach it, and then we can make it more or less secure? Or is it something on a smartphone that will just get stolen or lost and then somebody has all of our data? Which operating system are we going to run it on? Okay, and what kind of privileges can we give the users there? And we can try to understand what kind of network access is there. Is it only authenticated access? Are we over secure protocols, or are we doing everything over, over Telnet? So we really have to understand what the requirements are for the application in order to get through. So for the malware buster, we want it to be secure, right? We want it to be as super secure as it can because we're a security product. And we saw before with the mushrooms, we really need to make it secure. So for the malware buster, for example, we're going to say it has to be very secure. We'll see how we do that. Access will be for the system, for the security team only. Okay, which means that we can do something very sophisticated, okay, and very granular, and get it better. Access will be only for administrators. So we don't have to worry about any user getting onto the system and maybe messing things up, because only administrators will have privileges there. We can understand that what we're doing is not a toy, and what we want to do is install it on Linux and maybe use SE Linux to get that, to get it higher privileged and more secure, because I don't know about you, but I trust Linux better than other operating systems. We want to put it, part of the requirement is that we're going to want to put it behind the wall, okay, or behind the firewall, and make sure that no direct access can really reach our malware buster product, our platform from the outside, because we want to make sure that it's protected. But we do have to remember that we have bad guys or white walkers or malware that's always going through our system and going in and trying to pass the wall in order to get to our malware buster. So, I mean, we have the malware that's actually going to be running on our system. So even if we block the access, we're letting the bad guys through, and we have to understand how we're going to secure that. So if we take that, our recommended setup is going to be behind the firewall to protect our malware buster. We're going to let only administrators access it to remove the threat of users messing things up. We're going to put it on Linux. And this is what we get from our requirements. Next, we go on to the design stage, right? The next thing, the SDLC and software development lifecycle that we're trying to secure. And when we get to design, we start with even more dilemmas. We start to really ask questions about how we want to do it. Do we want to make it more usable? Do we want to make it more secure? What kind of defaults do we want, right? And why is that an issue? And how much do we take the user and try to lead them into making the right choices? So we first have to decide if we want to have a simple system, right? Turn on, off, do that. Or if we want to say, like, with a lot of buttons, we really have to control everything, but then the administrator might mess things up a bit more. When it comes to usability, I want to bring up, this is Avi Duglin, is one of the heads of the Israeli OWASP chapter. And this is Avi's law of usability, where security, the expense of usability, comes at the expense of security. Okay, if we try to say, we have to make our application a bit more usable because otherwise administrators won't understand how to use it. And, maybe it'll come at the expense of security a bit, but it'll come at the expense of security. Okay, and our system will get compromised. So we really have to make sure that we make things more secure and not just make them nice and usable and fun to use. What kind of defaults do we want for our system, right? So we have two examples, right? Of course, we're saying, we're cyber people, we're security people. Of course, we want it to be as secure as possible. And we want to block anything that looks suspicious. We want to log it all. We want to scan all the files. But if you bring that to a customer and you try to install it, it might just block his network completely, and then they won't buy. Okay, and then you say, okay, so maybe I can't make it all that secure and close everything. Maybe I actually want to start with something that's a bit more lenient. Okay, that if something goes wrong, maybe it'll let the file through so that documents can actually get through the system. But later on, we'll advise the administrator to block more and more until he gets it right. So That's why the usability and the security can actually conflict sometimes, and we have to understand how to do it. We want to think about which ports we're letting open, right? We want only secure ports, only those who are supposed to be, only privileged ones people should be able to get through. Otherwise, we might have a never-ending story of breaches coming into our system. And then there's more and more and more questions that we really have to understand how we want to do it. For example, how long of a TCP connection do we want it running, right? Do we want to let all the data come through? What if someone's downloading a 50 gigabyte file, right? Or a 2 gigabyte file? Right now we have to take this file and we have to keep it on our system that can DOS the system. How many signatures do we want to go back like to the beginning of time, or do we want to only use the things that are lately being seen? And what kind of emulation, right? If I have malware that, installs itself on my computer and then doesn't do anything for the next, 2 weeks, then I can't emulate something for 2 weeks and let the file only get downloaded later. So we have some compromises between security and usability that we have to understand what we're doing and make sure that we're getting them as secure as possible. One of the ways of doing that is, of designing things right, is using threat modeling. Okay. How many of you know how to threat model? Okay, a few people. So I'm going to claim now that you all know how to threat model, and then we just have to do it on security. I heard this on the Application Security podcast. It was something that Tony Vargas had said. He said basically, when you walk out of the house in the morning and you step out holding your son's hand and you hear a dog barking in the background and it starts raining and you hear a car coming down the street. And basically what you're doing at that point is you're looking out to make sure the dog isn't right here. You make sure you're both putting on coats so you don't get all wet. And you won't let your kid run to the street because you hear that there's a car coming, so you know it isn't safe right now. And basically what you were just doing, you were threat modeling. You were understanding the threats, you were understanding what you're trying to do, and you were making sure that you get it securely and you get it done right. So that's threat modeling in a nutshell, and that's basically what we want to do here. So what do we do with threat modeling? In the past, we always used to come to the developers and say, okay, what can go wrong in your application? Then developers say, what do you mean? We don't have any bugs. And nothing can go wrong because we implemented it just the way we're supposed to, right? That's the way we all do it. So we can't ask them what's going to go wrong. We have to assume something's going to go wrong and ask the actual questions of, why are we building this? Okay, what are we trying? What needs to get right? And what's going to be the price if that doesn't happen? If something actually will go wrong, because we're assuming that something will go wrong. And when we ask these questions of developers, then we can try to understand the pitfalls of where we have to fix things. So this is really good threat modeling, is understanding the business needs and the risks if something or when something will go wrong, to try to model it better. So if I take our design and I try to threat model it, and I'll dissect it to these different areas. I'll have the trusted zone, which is where the user is. We have the completely untrusted zone, which is out there on the internet. And then we have the area of basic trust after the firewall, right? Because we already filtered out all kinds of protocols that are accessing us, and maybe we had an IPS there and things. And then the file will reach the malware buster, and now it's ready only, we know that the malware buster is now safe just to take those files and try to run them and see what's happening. I just want to say, all the things that I'm showing, like with the malware buster thing, it's not that this is the one way to go right. Okay, it really depends on what your business needs are and what risks you're willing to take when you're developing. We also want to threat model the malware buster itself, right? Because we have to understand the different components in there. Is the whole malware buster just one single trust zone? Like I said before, right? It comes through. If it passed the firewall, then we're safe, right? Are we? Or are we not safe? Which different parts do we want? What are the pros and cons to each of these approaches to understand if we look at the malware buster as one complete system, or if we try to break it up? So if I break it up in there also, then basically I got my front end, I got my output over there, and then I have different parts inside. So I have my operating system that I'm running on. I have the software that prepares, decompresses, dissects the PDF or the Word file into the different parts. And then I have my actual analysis that I'm doing on signatures and emulation and all that. So these are my different components. And now I want to understand if I want to put up barriers. And if I do put up barriers between the different components, I have to make sure these barriers are good. Okay, that they aren't just that simple to figure out and bypass. So, talking about pros and cons. So if I take multiple trust boundaries, right, and I take each of those components I showed inside the malware bus, and I say, okay, each of these I want to make sure that they are, I don't trust between those boundaries, but rather I look at each of them separately. So basically, my pros are that each component handles itself, right? I can update it easier. I know what's happening inside my component. I can take care of it. The cons are that I might have duplicate checks, because I had, I checked the input in one place and then maybe it didn't change, and then I'm checking it again in the other one because nobody trusts each other. But on the other hand, you can also get really untrusted data that goes deep into the system and only then gets caught and understood that we have something bad there. If I have a single trust boundary, then it's basically the opposite. The validation at the input and at the output only, and I don't have to validate all around. But the cons are that it's a lot harder at the input to the system to understand what might go wrong deep inside, and then I might get things wrong. Programming languages, and here's also the cat. Programming languages are also a big part of the choice of how we want to develop our system, okay? If you come to the developer and you just say, here's my requirements, part of it is also the developer and the design has to understand if he's using the right languages to develop the software and make it right. So, does it work on a virtual machine? Right? Do we trust a virtual machine? What are the language's pitfalls? What kind of compiler am I using? Can I trust that? I really have to understand what I'm using and what I'm developing, that I'm using something right. So here's another, just a quick table of differences between high-level languages, low-level languages, right? How much do I have to deal with the memory management? Which again, on one hand, if I deal with memory management, I can really make it very safe. On the other hand, if I deal with that, I can also get into buffer overflow bugs and issues like that. Performance can be an issue. So one of the combinations that I like is using Python on the front end, right? It's easy to update. It's easy to manage. It has a lot of add-ons. It has a lot of tools to do REST APIs and things like that. And I have the C++ running on the back end, running in the deep system way below once I trust the data that came through, because it's much more efficient and it'll work much faster. Another question we want to ask ourselves is, what about open source? Okay, do we want to use open source libraries when we are developing our cybersecurity software? So, can we trust open source? Right? I mean, we know Linus's law, right, from Linux, that he said, given enough eyeballs, all bugs shallow, right? Because everyone's looking at it, so we have all the bugs. But on the other hand, everyone knows our bugs before we do. One of the main problems with open sources is that if somebody writes an open source and makes it malicious, or somebody was able to change an open source, then basically, if a lot of people are using it, they can take over the world. Okay? And we really have to be aware of that, because it means that the bad guys are trying to get their code into open source. We've seen it recently a few times on GitHub that people were able to put in malicious code, and basically then they can take over the world. There's also a great paper written by David Gibertson. He wrote up a blog where he said, this is how I took over all of your data. And basically he wrote up a thing where he said, I wrote an open source, everyone is using it, and my open source is able to extract data and send it over to my servers. And if you think that you can find it, if you think that you'll figure it out by looking at the code, you won't, because I've changed the code around and played with it and done splits and maps, and no signature will actually figure out what's happening there. And it'll go through. At the end of the blog, he says, okay, this didn't really happen, but you really have to beware and understand what went, what are the dangers of using open source software. And then, pardon my French, but you can encode things with things like JSFuck. This is actual code, okay? You can actually write JavaScript code with, I think it's about 6 characters, okay, and encode everything. you have no idea that this says alert 1, but you can write whatever you want here. And if the open source is using things like that, it's basically like writing assembly code, which there are people who can read it, but most people won't. So I don't know if the enough eyeballs law will actually work here. And so if we have open source like this, we're in trouble. Then there's a story of like LeftPad that broke NPM. If you know this, the developer, there was an open source called LeftPad. Basically what it does is it pads left. Okay, it doesn't do much more than that. This is the whole open source, these 12 lines or whatever. And basically he got into a fight with the NPM guys, and he just took his open source off the NPM, the Node.js libraries, and basically that broke builds across Node completely because everyone was using LeftPad, or dependencies of dependencies of dependencies that were using it, and basically he was able to break that. Then there's also the issue of typo squatting. So we know typo squatting in URLs, right, where you get a URL that kind of looks like it, but it isn't really. But we also had, this is from an article from last week, where they found more packages in the PyPy, in the Python libraries that were, instead of simple JSON, it's like simple JSON. And basically they were very, very similar. They did the exact thing that the regular library did, except it changed. For example, one of them I think changed the Bitcoin wallet of something to like the malicious guy's Bitcoin wallet, said all payments go through to him. It stole data. It got reverse shell access. Things are very difficult to catch on to. So when we take the open source, we have to understand that updating open sources are really, really, really vital, because all the bugs are public and everybody knows what your bug is. This is from the table from Mitre, which I took a couple of weeks ago, of the number of bugs, of CVEs, open, in the past few years, and it's growing. Okay? And so if we have open source software, we really have to stay up to date. We really have to always check on GitHub, on issues, on websites and newsletters, wherever it is, and understand if we have open sources, because we have to update them. And then you might ask, okay, but how will I find all my vulnerabilities and know that? So basically you can use tools, free tools like OWASP has the dependency check, which checks your dependencies and then checks to see if there are any vulnerabilities on the versions that you are using, and tells you, you should upgrade to the next version because it fixed it. And then it complements it with dependency track, which basically keeps that list of the open sources you're using. And if a new vulnerability comes out, it will alert you immediately. So you can use those tools. You can also use commercial tools like Snyk or WhiteSource or BlackDuck to basically do the same kind of thing. They go through, they check your vulnerabilities, and they warn you. So taking that, I'm reminding again, you cannot ignore software updates for any software, because if somebody's using my software was vulnerable, they have to upgrade it, and also the open source. And the reason that you can't ignore it is for two main reasons. One is bad publicity. Okay, you can have the shame of getting onto Project Zero, for example. This Symantec's endpoint client that was basically destroyed, where they said, that you were using libraries, open source libraries, which are great, but they weren't updated in 7 years. Okay, and so they were able to break the endpoint software. And this is something that you don't want to have to your software. The other example is getting hacked, right? And I don't know, some of you might have seen this slide already, the Equifax timeline. So the Equifax breach was one of the biggest breaches in American history, with a number of records that were stolen. But basically, the timeline here was that there was a vulnerability found in the Struts open source in February. Okay, the vulnerability was patched already at the beginning of March. Okay, this is patch released. Then right after that, there was a cert advisory. Everyone upgrade. Okay, and at this point, everyone should have updated. And what happened with them is that they patched it only in August. Okay, this is the patched, and in May they were hacked. In other words, there were 2 months between the publication and the hack beginning. Okay, where they should have upgraded their software and they did not. And then it took them a few more months to find out that they were actually breached. So if there's an upgrade, if there's an update, especially if it's a security one, you got to do it. So getting back to our design, the question is, do you trust open source? Okay, can you trust open source, and do we? actually trust it. We were getting onto the development, so Steve Ballmer's developers, but basically best is to use best practices from the field, understand how to do it, use books, use online resources, look at really best practices in like the OWASP cheat sheets. They're really great explaining how to do things right. In the development, we have to understand, how do we want to write the code? Do we want, as I said, do we want to have everything be protective, right? Do we always want to check for null? Or can we say, no, we have some things that we've already checked for those inputs. We know that they're safe, and then we can go on. So back to developing what we were talking about in the design stage. What if things change, right? And you get something new. How do you do it? So the hint is to make sure that the design is still secure, right? You did the security design review at the beginning of but once you did the security design review, if something changed because something doesn't work out, you have to make sure that it's still secure and you're not breaking everything completely. And when it comes to open sources, you got to choose wisely and make the right choice so you don't get crushed. Almost the end of the SDLC is getting to verification, and testing isn't only QA as an external team, but it's also testing that developers should do. If I take Albert Einstein's quote on how to solve a problem, he says he would spend 55 minutes thinking about the problem, 5 minutes actually solving it. Okay? When we come to write unit tests or system tests, a lot of times we spend a lot of time developing the application, and then at the last minute we go and we write some tests just to make sure that it goes through. And really what we need to do is we have to spend a lot more time writing the tests, thinking of the tests, doing them right, so when we develop our software, it can be tested really well from the start. When do we run our tests? The hint is shift left. Okay? We run the tests early on. We don't wait for the end to start running our tests. We want to run our tests from step one on the developer site and not only wait for much later. So here we also have a lot of questions. What's the percentage of tests that we want to pass? How many tests do we want to run? How much of the code needs to be covered by tests? What if automatic tests fail? How do we get on with that? There are a lot of tests. There are a lot of development tests that we have to think about. We had our threat modeling, so we want to take that and we want to design our tests according to the threat modeling, right? Let's not forget what we've already done to secure our applications. So we want to get it right. We want to do static code analysis. We want to do dynamic analysis on our code. We want to get that through. We have QA testing, right, which is a lot of product testing, right? Does it work? Does it not work? We also want to check if our testing is secure. We want to do pen testing. We want to check for open ports that we didn't expect. We want to check for open sources that suddenly send out data, call home to check for updates, for example. We don't want our software to be doing things that we didn't know about. So again, here's like some decisions I'm taking for the malware buster. I don't want to get into the details, but we can, some of the things that we've done, right? So we want to have code coverage, but 100% is really difficult to get into. If something in the automatic testing fails, we got to fix that right away, but we have to fix them all. The last stage is maintenance. And the maintenance is once we released. Okay, so we went through all the stages. We got our software out there. Our cyber software is doing great. And now we have to maintenance. Why do we need to maintenance? Because suddenly discover a security bug. We're already working on the next release. And suddenly we realize that there's a bug there. And then we see that it's a test that we missed in the previous one. And that our previous release is just as vulnerable. We have to decide what we do with that. How much data do we publish to our customers or to the world? Who do we tell that we have an issue? How do we tell them? How do we update? But we have to release and we have to take care of that. And of course, if our open source library is vulnerable, right? So this is something that we couldn't have known before. We only found out now because it just got published that an open source is vulnerable. But if that happens, we have to. Do we want to always upgrade? Do we want to first check to see if we're actually exploitable? Because, for example, if the open source is vulnerable only if you're using science specific, then yes, you have vulnerable code, but you can't actually exploit it because we're not using that specific thing. Or, for example, if it's a port that's open, but we have the firewall, so we're protected from that, right? So you really have to understand sometimes and decide if you always want to fix things or only wait if we're exploitable and then take care of it. And of course, if we're using an open source that's using an open source, and that one is vulnerable, we have to understand if it goes all the way up the chain or if we're safe. And then the question is, because we're cyber software, is every bug a security bug? Okay? And this is a good question. Because if we take some examples, is a memory leak always a vulnerability? Right? I think the answer is no. If a memory leak is caused by saying in my software, I don't know, some maintenance I do, I'm writing logs, I rotate logs or whatever, and I have some leak there, but it's not something that's actually caused by an external attacker, then maybe that isn't a vulnerability and it's just a small memory leak that I have to fix. Okay, it's a bug that I better take care of, but I wouldn't call that a vulnerability. What about crashes? Again, if an external attacker can send a specific file or a file format that will crash my system immediately, then yes, that is a vulnerability. Okay, they can deny service. But if it's something that happens internally, maybe not. We have to decide how we handle it and do we think of it as a vulnerability and fix it. What about misconfigurations? If I have conflicting settings, right? I don't know. One place says that I don't decompress files, and the other one says to test zip files. Then what am I testing? How am I going to do it? What am I doing? We have to understand how to do that. And one of my favorites is evasions. Okay, an evasion to the software, is that a vulnerability? I mean, you can always find more and more evasions, and the question is how we handle it and what we do with it. And the question is an evasion, is it just, okay, I have to upgrade, I have to send out a new signature, I have to find another way to dissect this PDF, or is this an actual vulnerability that we have to handle it? So, to summarize the malware buster decisions, they're here on one slide, but again, it's not that this is the way to go and this is my recommendation, this is what you should do. It really depends on your application and on your resources and on the time and things like that. But basically, we have to make sure that we take decisions that are secure. We take decisions that we can stand behind. We take decisions that we can handle, and that we always have a way to upgrade our software and have an extra strategy in case we need to get better. To summarize the whole talk, so really, when you write any sort of software, you have a lot of dilemmas about how to do it, right? How you want to develop it, who's going to develop it, and how much time you have, which languages you're going to use. My claim is that when we write cyber software, then we have a lot more to think about and a lot more dilemmas, because it's not just something that will crash, it's a network that will crash. Shifting left is really vital to the process. If our developers don't understand security, and it starts from there, okay, if our marketing doesn't understand security, you can even go all the way back to there, right? Then they won't be able to sell something to try to create a product that will actually be secure. We have to really take the security to the beginning as we can and make sure that all people along the way know, understand, and can implement security. And one of the main ways to do it is to have clear guidelines within your organization about how to write code, how to develop code, how to test it, and how to do all the different parts that you have to do in development in order to get it. So, thank you for having me, and thank you for listening. You're welcome to contact me on various ways.
Thank you, Ethan. Now it works. Thank you, Ethan, for this very interesting presentation. So we have time for questions.
Thank you. I was wondering, how do you relate code quality or development, good development processes versus security? Can you do a secure software, cybersecurity software, with poor or not state-of-the-art development practices and quality?
You can, but you won't get something that's very quality. Or maybe I didn't understand the question.
Well, the point you exposed the different milestones and how you add security to them, but it takes the basic point is that you already have unit testing, you already have design meetings and so on and so. So you have already a software factory which is running quite well. You have already developers who are attending training, so they can just attend security training on the top of it and so on. But if you miss all this framework, if you're one of those company which is not a software company, but everyone is now a software company, how do you can you get it without having good developers and good processes around development to ship a secure product?
So I think you really have to add those. You really have to add them in. I can say, for example, by us, we always had a security training, okay, for years already. But the security training was basically focused on our main product, which was developed in C, C++, and all the examples are with that. And then we started doing more mobile. Suddenly mobile comes in, right? We don't have any mobile developers. So we get some mobile developers. And then they look at the training and they say, we don't understand it, right? You know, CSTR bugs with buffer overflows, that doesn't mean anything when you're talking about Java, right? And then we had to create something to add that in as well. You're right. And the main problem, the problem that you're bringing up, I think happens a lot of times in startups, because startups just have to get a product out and they really don't care about security. And I've seen startups that do banking and have zero security because they have time to market. And it's really something that then you have to add in, and you have to, and the difficult part of adding it in, is really that the developers were used to one thing, and suddenly you're saying, wait, before you push any code, you have to have training, you have to have code review, and then they say, whoa, I can't work like this, you know, and you have a risk of them leaving and going somewhere else. You're right, it makes it a lot more difficult if you don't have the basic infrastructure, but it's something that you really have to add in. And that's the shifting left. It's instead of saying, we have our security guys down there, they will do the testing, we say, let's pull it back, and let's add it in to all the different stages to make sure that we get it.
Any other question? Right there.
Well, my question is twofold. First, do you think it is necessary that everybody, I mean the general public, understand what cybersecurity is to obtain cybersecurity? And if so, how would you propose to do it? I mean, to make people understand the necessity of cybersecurity.
I think that today almost everybody knows, they don't understand cybersecurity, but they know cybersecurity. They know it exists, right? Everybody knows that they can get hacked. Everyone goes around with a phone that they know that has updates all the time, and it says security updates. So, I mean, even my mother knows that, you know,
yes,
software can.
I agree that people knows what cybersecurity exists, but I'm more about the importance of it. Like, it is something you cannot just step out. You have to think security, because the real problem in security, I think it's the user. So if we give them the means to understand what's secure, what's not secure, we can get better security. I mean,
right.
And so how can we do that? How can we talk to people that doesn't have any technological background to understand the importance of it?
So I think people have to understand cybersecurity, but I don't know if they have to understand it to the details that you and I know it. Okay, if I drive a car, I know I have to wear a seatbelt, but I don't understand exactly how the seatbelt works and what kind of, you know, what it's made out of that makes it be able to be elastic and stop me, and how secure the car is. I just know that it is or has a level of security. And I think that's what the general public would have to understand. They have to be aware that there's a cyber threat. They have to be aware that there's a security issue, but they have to put their trust in us that we're protecting them the right way. That's what I think. And the way they do it is by reading, if it's blogs or news articles or anything like that, that makes them aware of the actual threats with cyber.
Okay. Well, thanks.
Any other questions? Yeah.
So a bit of a derivative question of the previous one. Often in the development world, people will say, okay, we don't care. We don't want to be perfectionists and make perfect quality. We want to release early and fix as people complain. And many of the big vendors, including the security world, are working like this. So what are good arguments, in your experience, to convince people not to abuse of this approach and to include quality early on the left?
It's a very good question. Basically, the only way that you can, the way that we do it, okay, when somebody comes and says, there's a bug there, but like nobody will really find it. The answer is, first of all, we found it, so it's already out there. Number two is, what do you do with the customer, or with when a researcher will come over to you and say, I was able to break your software. Okay, then what's your answer to them? And that's the place that a lot of times catches people, because at the end, you have to give an answer to the customers, you have to give an answer to the public, and you have to say, my software is broken because. And would you be able to answer them and say, looking straight in their eye and say, no, it was safe enough the way it was before. And I think that's you have to really understand the risk. If you go back to threat modeling, you have to understand the risk of somebody finding that vulnerability and how you would mitigate and how you would answer it.